SolidWorks Simulation, Lecture 7, Part 4, the effect of pre-stress on the frequencies of a structure. Now, enter sketch mode in a new part. Draw two circles, concentric circles. The inner circle is 10 millimeters. The outer circle 120. And extrude it to 1 millimeter. So this is a CD plate. I'll save it. And for the rotating center, I need to define an axis, a z-axis. So I'll choose this surface and define an axis. Or in feature toolbar, you choose axis and define the z-axis for it. Now, I have already finished with the 3D model. So now I can open a new study, frequency study. For the preparing steps, I need to open or add in the software. And second, I need to load the toolbar. And the third preparing step is to organize or arrange the toolbar, because I need to use rotation speed for this CD plate. So I need a centrifugal force tool. If this tool is absent in your desktop, you will add customize commands by adding simulation. And this is the centrifugal force tool that you can drag and drop here. And this is the gravity, which is not necessary right now, so I do not use this. I simply drag this centrifugal force to the toolbar. Okay, so now I have already finished with the third preparing steps. So I'll go ahead and proceed with the 6 steps for CAE analysis. The first one is drawing a model and open a study. The second is defining material, and I'll give it a polymer material, PC high viscosity. This is a material used for compact disc. And for the third process, I'll mesh the CD and hide the mesh. And I'll fix the inner circle, inner surface, and apply a rotating speed with a rotating center at the z-axis. And I'll choose another unit for it, because the radian per second unit is very difficult to use. So I change into metric unit with RPM unit, and I give it a 60 RPM rotating speed. And this is the rotating acceleration, which is not necessary right now. I'll define the a very low rotating speed on this CD plate, and I'll reverse the direction of rotation so that it is counterclockwise. So I have finished with the 4 steps in CAE analysis, which is called preprocessors. Now I can proceed with the solving solution phase, but before I do that, I need to change the number of frequencies that I will calculate. I'll let it calculate 11 frequencies and rotating and vibration modes, and also check the automatic solver selection. So the software will choose solver for me, and then I can calculate the frequencies. And I'll save the frequencies here by right-click the mouse, list the frequencies, and this is the frequencies of the structure at lowest rotating speed. Now I will change the rotating speed to a higher rotating speed, such as 2400 RPM, which is much higher than 60, right? So after changing the rotating speed, I'll implement the solution phase again. And now I got the result for higher rotating speed. And we can compare the results. And this is a natural frequencies, the natural frequencies for the structure at lower rotating speed. And this is that in higher rotating speed, rotating speed of 2400 RPM, and this is for 60 RPM. You can see from the frequencies that the frequency increased by increasing the rotating speed of the CD plate rotating speed. But as I said before, the external force does not affect the natural frequencies of a structure. Why is a rotating speed, which is also an external force, why does it change the natural frequencies? The reason is that when you increase the rotating speed, the internal stress of the structure increases. And when the internal stress increases, the rigidity or the stiffness of the structure increase. Once the stiffness is increased, the frequency of natural vibration will increase also. So that is how the centrifugal force or rotating speed will increase the natural frequencies of a structure. So in this case, the frequency increases with increasing rigidity or stiffness of a structure by increasing rotating speed. And this phenomena is used in, for example, high-speed spindle and high-speed bearing, and also high-speed rotating DVD player. In which case, when a part is rotating at very high speed, the frequency will increase also. So you will get some frequencies which is not available, not detectable in lower frequencies or even in statics condition. So there is a term that is called ghost frequencies. Ghost is not there, right? So ghost frequencies means that in high rotating speed you get some frequencies which is not absent, which is not presented in lower speed. So in this lecture, the most important thing is that you have to distinguish between external force and that of the pre-stress condition. The external force does not affect the natural frequency of a structure. But once the external force significantly change the internal stress, it will create a pre-stress condition for the structure, and the structure's rigidity or stiffness will increase, and then the natural frequencies of the structure will increase. So this is a pre-stress effect of natural vibration.